In this class, we'll discuss about linear programming simplex method. So in simplex method, the first step is standard. We have to standardize the form like this. Any symbols over here will be writing the less than equal to sign. We have to convert into equal to sign by introducing slack variable. Like here, we'll write 2x1 plus 2x2 plus x3. X3 is nothing but is the slack variable is equal to t, and then after here this one is 24. Okay, then after 2x1 plus 4x2 plus x2 plus x4 equal to 24. So we introduced slack variable, that is x3 and x4 as a slack variable. Okay, then after we have to also arrange this one in this way, that is z minus 6x1 minus 8x2 equal to 0. So next one is that we have to arrange this one in the coefficient simplex table. So z x1 x2 x3 x4, the RHS is here. Here in this row it has the objective function, that is the z, and then after slack variable x3 and x4 I'm taking over here. So the coefficient of z over here is, this is 1, x1 is minus 6, x2 is minus 8, x3, there is no x3 over here, so I'll write 0. Over here also it will be x4 is 0, and RHS is also 0. Similarly for this row, z would be 0, x1 would be 2, x2 would be 2, x3 is 1, x4 is 0, and RHS is 20. Similarly for x4, we'll write x4 row, that is for this row, that is z is 0, x1 is 2, x2 is 4, there is no x3, x4 is 1, and then after RHS is 24. Okay, so now so step 2, we have prepared this simplex table by writing the coefficient of standard forms in the table. Okay, this is done. Third step is that optimality test. Does the top row contain negative value? Yes, this is the top row. Okay. Yes, it contains the negative value over here and over here also. If no, then the corresponding values are the optimal. That means z, if it would have been in the positive values, then we would have told that z is equal to 0 and x3 equal to 20, x4 equal to 24. But it is not there. Okay, so if it is not uh, in the optimal value, then we have to find out the optimal value. How we will find out the optimal value? It says that step 4 says incoming, we have to find out the incoming variable, lowest negative value of the top row. Which is the lowest negative value? That is, you can say x2. x2 is the lowest negative value. Minus 8 is there, and so we, and then after outgoing variable following the minimum ratio rule. So how we'll find out the ratio? We'll find out the ratio in this way, that is 20 over here, this row, that is the lowest value, which is we have got, this is as my incoming variable. Okay, so now we'll find out the ratio over here. So we'll divide RHS value, this one, divided by 80, 20 divided by 2. 20 divided by 2, that becomes 20 divided by 2 equal to 10, and then after 24 divided by 4 equal to 6. Okay, then it says that following the minimum ratio rule, this is the my ratio. I got 6 as 1 ratio, 10 as 1 ratio. So following the minimum ratio rule. So minimum ratio, which is the minimum ratio out of these two, x4 is the minimum ratio. Hence, this becomes my outgoing variable. Okay, so over here it would be written as x2. Okay, and then after intersection of incoming variable and outgoing variable. This is my incoming variable. This row, this column is my incoming variable, and this row is my outgoing variable. So intersection point becomes, this one becomes my intersection point. Okay. Now I have to make this one as 1. How shall I make this one 1? I can make this one 1 by dividing this one divided by 4. Okay, I have on in order to, so as per simultaneous equation, I'll divide by all the element with 4. Okay, so this becomes 1 by 2. This is 1. This is 0, and this is 1 by 4. This is 6. Okay, now other values has to be converted into P, that is the pivotal element, to be converted into 1, and incoming column to be changed to 0 by multiplying pivotal row. This one I have to multiply. I have to multiply how much with, that means this one has to be converted into 0. Okay, how shall I make this one equal to 0? If I multiply this one with -2, I'll multiply this one with -2. Okay, if I multiply with -2, then how much it would be? -2 into 0 is 0. Then after -2 into 1 by 2, this one would be -1. -2 into 1, this would be -2. This would be 0. This one would be 1 by 4 into -2 minus 1 by 2. This is -12. Okay, so similarly here is -8 is there. So this pivotal row has to be again multiplied with +8. So 8 multiplied with 0 becomes 0. 8 multiplied by 1 by 2 becomes 4. 8 multiplied with 8, 8 multiplied with 1 becomes 8. 8 multiplied with 0 becomes 0. 8 multiplied by 1 by 4 becomes 2. 8 multiplied by 6 becomes 48. Okay, now I'll just keep it over here. Like earlier, we have our intention to make this one equal to 0 and this one equal to 0. Okay, so for doing that one, we have multiplied the pivotal row with that of the corresponding values. Like here it was required -2, so we multiplied -2 over here in order to make this one equal to 0. Okay, here also we are our intention is to make this one equal to 0. Okay, so now I'll add this value with that of this value. Okay, so the my incoming variable becomes this one has come over here. Okay, and then after here I'll write that is L, which was the incoming variable. This is x2 and this is outgoing variable. So outgoing variable gone out and incoming variable has come over here. So for that reason I am writing. So now I'll write the pivotal row as it was earlier. So I'll write 0, 1 by 2, 1, 0, 1 by 4, and then 6. Then after for this one, 1 plus 0, this is 1, minus 6 plus 4 equal to 8 minus 8 equal to 0. If 0 plus 0, 0, 2 plus 0, 2. Okay, 48 plus 0, this is 48. Okay, then after for this one also 0 plus 0, this one and this one. Okay, so 0 plus 0, 2 minus 1, that is 1, 2 minus 2 is 0. Okay, then after 1 minus 0, this is 1. Then after 0 minus 1 by 2 minus 1 by 2, 20 minus 12, that is 8. Okay, now it says that step 4 says that iteration of step 3. What is the step 3? Does the top row optimality test? Does the top row contains negative value? Yes, it contains a negative value. So it is not a optimal. Okay. So in order to make that one, what we have to do now? We have to find out the. This is my, so x1 becomes my incoming variable. Okay. Now I have to find out the ratio. So which one? I will divide. The ratio of this one would be 8 divided by 1. Similarly over here 6 divided by 1 by 2. Okay, so this becomes 8 and this becomes 12. Okay, so it says that following the minimum ratio rule. So minimum is 8, that means this becomes my outgoing variable. Okay, so as per now this should come over here. Okay, so here we are going to write this one. The row would remain same as it is. Here what we have to, earlier it has been converted to 2 and now x3 will also be changed to x1. Okay, now the pivotal row will be written as it is because this is 1, already 1. We don't have, like in the previous one, we have divided with 4. We have divided with 4 in order to make the pivotal element equal to 1. Here already this one is 1 over here, so we'll write as it is. That is, we'll write pivotal row in this way: 0, 1, 0, 1, minus 1 by 2, and then after 8. Okay, so in this way we are going to now write for the other values, like we'll just multiply with plus 2 over here and we'll add over here. Okay, so while adding, after addition of that one, that means after multiplying with this one with -2 and adding over here, this row multiplied with -2, and then after we can add over here in order to make this one equal to 0 and this one equal to 0. Okay, so if you add this way, and for this one we can multiply with -1/2 in this pivotal one. Okay, and then after we can add that one. So after doing that one, we'll be getting this one as our values. That is already as I have told, so I'm not repeating the thing. I'm just writing straight away. Okay, so and this becomes 0, 0, 1, -1/2, 1/2, and 2. Okay. Then after again we have to follow the step 3. What is that step 3? Optimality test. Optimality test says that does the top row contains negative value? So we have seen over here that in the top row there is no negative value. Hence we'll say that how much is our z equal to 64 and x1 equal to 8 and x2 equal to 2. Okay. If we put the values over here, okay, 6 multiplied with 8 plus 8 multiplied with 2, this one will become 64. And if we put 2 jar 8 plus 2 jar 2 will be less than equal to 20, and 2 multiplied with 8 plus 4 multiplied with 2 will also be lesser than 24. So this is the example of simplest method of linear programming. Okay, and here we have used only this particular symbol. Okay, that is less than equal to and how. So we have situations like here. Okay. Here you can see the objective function is given this way. This is the maximize one, and then after they have different the constants. Like we have over here 3 constants. This is constant 1, this is constant 2. Okay, so 2 constants are there. This is non-negativity. Okay, so here they have given objective function and 3 constants over there. But here the difference is that they are using this equal to sign. Here greater than equal to sign. Here less than equal to sign over here. So for equal to sign, here it is written convert equal to equal to sign of simplex method by introducing artificial variable. Here x3 is introduced as the artificial variable. Okay. Then after here greater than equal to convert equal greater than equal to sign equal to sign by introducing surplus variable, and surplus variable is deducted from here minus. So this is the surplus variable, and this is the artificial variable. Okay, and here in this equation we have only introduced slug variable. Okay, so when we are going to in this way we can introduce this one, and after doing this one what we have to do is that in the objective function we have to make necessary changes. Okay, so in the maximization one, what we have to do is that we have to deduct a higher coefficient. Like in this case, I'll use 100 x3. X3 is my first artificial variable of first equation, and then after minus higher coefficient of next artificial variable, that is what this one. For slug variable, we do not have to do any changes over here. So this way it has been prepared. So and the remaining steps would remain same, but only thing is that it will start when first of all we have to make this one equal to this higher coefficient value. We have to convert that one into this x3 and x5 has to be converted into 0. Okay, how will make this one equal to 0? Any of means while when we are writing this particular equation, that is this first equation, so we have to write, we have to multiply, and then after we have to make, means this equation will become z minus 2x1 minus 3x2 plus 100 x3 plus 100 x5 equal to 0. Similarly, this equation will become, this will remain as it is. So when we are going to write the coefficient matrix at that point of time, what are the values over here? Z, x1, x2, x3, x4, x5, and x6 RHS. Okay. Here in this one we'll write Z x3, that is the artificial variable, and this one again artificial variable. Okay. And then after, for this case there is no artificial, so I'll write x6. Okay, and this one would be, it will be written as 1 minus 2 minus 3 100 0, then after 100 this one will be 0 and this will be 0. And for x3 row, I'll write this one equal to 0, x1 is 1, x2 is 2, x3 is 1, and then after other values x4, x5, x6, this one would be 6. Similarly for x5, I'll write z equal to 0, and this is 4, this is x2 is 1, x3 there is no x3, x4 is minus 5 is 1, x6 no x6, and this is 8 I'll write, and then for this row I'll write 3, this is also 3, and then after 0, 0, 0, this is 1, and this one will be 12. So first I have to multiply this particular row with minus 100, and I have to add over here. Based on that one, it will become 0. Whatever the result would be, because the changes will occur. Then similarly, with that output, after making this one 0, next one would be to convert this one equal to 0. Okay, so in the multiplication we'll find some minus value over here, another, and after that, because this is maximization, other norms, like all the norms of standard form is being prepared. Then after optimality test, incoming, finding out the incoming variable, then after outgoing variable, pivotal element, then after how much would be the column value, how you are going to change, making pivotal element 1 and other incoming variable 0. Okay, so the iteration will continue till it becomes all positive in the first row. Okay, so now we'll see this one as the in the minimize, how to deal with minimize. In the minimize also the norms, all the norms remain same, equal to sign or greater than equal to, or only smaller than equal to is there, what we are going to do like slack variable. So that remains same. Only in the minimization, artificial variable must have a large positive coefficient in the objective function. Large positive coefficient in the objective function. Here we have deduct one artificial variable, but in the minimization we have to add the large positive coefficient. That means plus 100x3 and plus 100x5 minus, and here it is plus. Okay, in the objective function. So ultimately it will become z minus 2x1 minus 3x2 minus 100 minus 100 x5 equal to 0. Okay. And incoming variable is determined by the largest positive value of the top row. Like here, incoming variable we are finding out by the lowest negative value. Okay, here the optimality test follows. Does the row contain negative value? Here it would be in the minimization. Does it contain the positive value? And then after highest positive value of the row, and other things like determining the lowest ratio and making the incoming pivotal element equal to 1, other value equal to zeros, that remains same over here in the minimization. Okay, so this is all about the simplex method in the linear programming for maximization as well as minimization. Thank you.